So it's again an awkwardly worded question, clearly. I mean, the linguistic quality of some of these questions is questionable, right? So anyway, the idea of the question should be pretty clear. It's asking for the empirical rule, and it's asking for a confidence interval, right? That's the right word for it, such that assuming the empirical rule applies, 95% of the smokers are in that confidence interval, okay? So how do we go about constructing that confidence interval? I want to use this word confidence interval because we'll be doing lab 7 and 8 purely about confidence intervals. So this is, in a sense, a precursor to that, or this is just pressing that a little bit. So what does the empirical rule say about 95% of the data? I mean, how many standard deviations do we have to? Two. Okay. And one more thing I want to mention about this question is important because we'll be doing, in part 1, you'll be needing this idea. Okay, so this idea might help you in part 1, in question 1, which is worth only 1 mark again, but it might help you do other things that you might have to consider. So we want to construct a 95% confidence interval using the empirical rule. So we want to look at this confidence interval. Again, it's about the mean. So we look at mu minus 2 sigma, comma mu plus 2 sigma. So the endpoints of the intervals are defined by those two expressions. So you take the mean and subtract 2 sigma to get the left endpoint, and you take the mean and add 2 standard deviations to get the right endpoint. Clearly. Did you guys cover how to construct a confidence interval like that in class? Not yet. You'll see that. Okay. So we already know from the displayed descriptive stats that the smoker's mean is 86.48 and the standard deviation is 16.21. So this will be just 86.48 minus 32.41, and this will be 86.48 plus 32.41. And if we subtract that, this will be, 54.07. That'll be 118.8. So 95% of the smokers' pulse rates, the smokers, because we use the mean for the smokers and we use standard deviation for the smokers. Remember, we got that out from the descriptive stats function earlier, and I recorded that because I knew this question would be coming up, right? So 95% of the values fall between those two values. So if the pulse, pulse rate's above 54 and below 119, 95% of the students should lie in that interval if the empirical rule were to be true. Now, that doesn't mean the sample follows the empirical rule exactly, but if the empirical rule were true exactly, right, then 95%, exactly 95% of the sample would fall within that range. Okay, that's a very important question. Any questions on that? And any questions on that idea? Yeah.
This question doesn't have anything on the computer that you have to dial in?
Yes.
Okay.
I mean, there is a calculator there you could use somehow, but you have to carry out this calculation. Yeah. Yes. Good question.
Check whether we can apply the empirical rule. We have to construct the histogram see if it's developing.
That's true. To check if the empirical rule is followed, you would have to construct the histogram and see if it is a normal distribution. However, the question assumes that it is in this case. But that's a fair question. I mean, it assumes that it is, so you don't have to do that, and you just take that as a given. That's your assumption in the question, right?
In case it's not given, you move on.
Yes. In that case, certainly, you would have to go through that process.
So when you want us to write this answer in a homework, you want us to just type it out?
You could write it down with your hand, leave a little space and write down with your hand, or you could just type it up in a way that's convenient to you. I don't need to see a sigma there. You know.
It's like that was the question. How would I put the symbol on the?
Don't worry about that. Just use X for it. Use anything for it. I don't mind that. I'm not picky about your.
But we have to show the working out.
Yes, you have to show the working for that. I mean, you just can't put these two numbers up there and expect to get the full mark, right? I want to see how you got there.
Can I try the last two steps without the formula up? Because I want to be able to get the symbols. Yeah.
Yeah, you can show this. Mean for smokers is this, standard deviation for smokers is this, and then do this computation. I mean, anything that shows me how you got the answer right. Some little things there. I won't be picky as long as you show me some way, right? I'm not going to be like extremely picky about it, like, oh, you missed this little step out, so now, no. Okay? As long as I see you understand the idea behind it. Okay, any questions about this? Because this is a key question. All right, so, yes.
Can you please repeat how you find how you found the meal for a smoker in the standard deviation?
Yeah. That came out in the display descriptive stats function.
Oh, okay.
So it was right here, right? And it was here, 86.48 at 16.21.
Oh, yeah, okay. Thank you.
That's a good question as well. That was basically lab 2. Okay, great. So I and G I'm going to leave to you because it's similar. You have to do a similar thing for non-smokers. Now, question 1, I want you to try by yourself. It's 1 mark, but I will say one thing about it, okay? So, can I erase that? Are you still copying that? Okay, erase that now? This one.
Is it the mean? Because I want to like write different words for the view for the first one, like two smokers.
Yeah, I mean, I don't want to get into the details of that question, right? You can write it up in a lot of different ways. Mu is the mean, but like whichever way you write it is fine. You can say mean, you can say, you know.
But mu is mean, right?
Yeah, the mu is the mean. That's a pretty standard notation for the mean, right? I don't know how you guys are called. What do you call the mean in the theoretical lectures?
We just write MEAM.
Oh, okay.
Or
You
like an
don't,
X to the bar on top of it.
oh, you sometimes that's the sample mean, right?
No, but we told this as well, but I just drawn it differently.
Okay.
But I have a longer answer.
I mean, if you want, I can call it X. I don't know. If that makes you comfortable. But it's the mean. I guess you guys are not used to notation. I should probably keep that in mind. Okay, I'll just erase that and move on to question 1, right? So question 1, I'll give you a hint for that. I can't go through it because I virtually did everything in question 2. I mean, the main things, and pretty much everything. So question 1, I want you to look at example 1, page 33. I'll just check that. For ideas on that. Yeah. And I want to mention one thing, that it's about a particular data set. So let's just close this Minitab data set and open Minitab again. And question 1 deals with a data set in the sample folder called the Pulse data set, pulse.mtw. And it's looking at only one column in the data set, the first column called Pulse 1. So I'll show you how to get that data set. You go to File, Open Worksheet. You click this folder to populate it. Right, click it now. And then you search. The search function is now active. So you write PU, and you pick the first file, pulse.mtw.
Pulse?
Yeah. It's confusing because we have Pulse as a column in our original smoking data set. Now we have the name of file, then we have another thing called. So
Professor, what did you click for it?
you click this tab over here. That's very key. That's very important. That's a good question. That's a very key tab. You have to click that. That's a very good question. And then you click open, and you just click OK. And you'll be dealing with only the first column for question 1. You'll be only dealing with that column, C1. Okay, that's the hint. The third hint I want to give. The first hint is that look at example 1, example 2, and the second hint, I guess, is that just look at this particular column for question 1. And that's all I want to say for question 1. It'll be 1 point, so not a big deal. Okay, not a big deal. All right, and that's a lab. I'll put the lab 1 over here, and I'm going to collect. I've already taken lab 2s. Okay, so I'm going to place